So we had finished up last week. We'd talked a little bit about centering, and we'd talked about sort of why we center. Now, centering is kind of turned into a semi-controversial thing in recent years. Kind of the rule was always, make sure you go through and center things to address collinearity between your interaction terms and your first-order effects. In actual fact, it doesn't have a practical impact on your actual analyses, but I would still encourage you to center because it helps with interpretability, and we're going to see why that works here in a moment. Okay, so we talked about centering, impacts of centering, and then we went through and talked about for our additive models, whether or not sort of we're getting any whether we can look at some of our moderation effects, right? And so we went through and centered, interpreted, looked at centered effects, and then with our additive model, right? If our question is, what's the relation of opiate use on role functioning at different levels of pain and PTSD, okay? Now, if we have just our straight additive model, right? So, and this is our regression equation. We got our expected value of our outcome, our intercept, our coefficient for centered pain, coefficients for centered opiate use, coefficient for centered PTSD. And with this model, I can, if my question is what's the relation of opiate use on role functioning at different levels of pain and PTSD, what we found is I can go through and I can throw in all sorts of different values for pain and PTSD. And Sean, does it change the unique effect of opiate use on my outcome?
No, not at all.
No, not at all. It doesn't, right? And so same thing. What's the relation of PTSD to functioning at different levels of pain and opiate use? Oops, something's back in. I can go through and I can change around and put in specific values of pain and opiate use. Sean, does it change the relation of PTSD with functioning? No, it doesn't, right? And so what we get with our additive models is no matter what other values for other predictors we enter, it does not change the unique effect of X and Y. It's constant across all other predictors. And so if my question is, what is the impact of my moderator on the association between X and Y, can I test that with a straight additive model? Nope, I can't, right? I need to do something different, okay? And so what we're going to do is we're going to start including interaction terms. And our interactions are going to give us a way to start testing hypotheses we have about some variable and its impact on the unique effect of sort of X and Y. Okay? So if our question is, we got a couple of questions here. Do opiate medications influence the impact of physical pain on role functioning in survivors of serious motor vehicle accidents? Okay. We got CJ. What is my base relation I'm interested in here for my first question?
The base relation.
Yeah.
Is pain on role functioning.
Right. Okay. And if I were to say, hey, does pain impact role functioning? That's my thesis. Is anybody going to be excited about my thesis? Chris is excited about my thesis.
Who cares?
Well, that's the thing, right? Like we already have plenty of evidence that yes, physical pain impacts role functioning, right? So that's not interesting. But CJ, what am I suspecting might moderate this association? Opiate use, right? So does pain medication use impact the relation between pain and role functioning? Okay, you're on a roll. What's my base relation in question 2 here?
PTSD and role functioning.
Right. If I say, hey, my thesis is to look at whether or not PTSD impacts role functioning, right? Who's excited about that? Chris C is excited about it. No one else is, because that's already been done. Like no one's interested in that. But what we're looking at, remember with our moderation, is looking at boundary effects. Like under what conditions does this association hold? And what types of things make this association stronger, weaker, maybe even change the direction. Okay? And so these are the types of things that we're looking at. And so what happens when I throw pain severity into this mix? Does that change the unique effect of pain on role functioning? Okay. So my multiplicative model for this example is going to be, here I'm going to have my intercept. I'm going to have a coefficient for pain, coefficient for opiate use, coefficient for PTSD. But then I'm going to have a coefficient for the interaction of opiate use and pain, and a coefficient for the interaction of pain and PTSD. And these are going to be the tests of my questions here. Questions up to this point. Okay. So, my opiate by pain interaction. This is going to test the hypothesis that the relation of pain and functioning depends on opiate use. Pain and PTSD interaction. This is looking at the impact of pain on, or PTSD on levels, the impact of PTSD on functioning at different levels of, differing levels of pain severity. All right. Now, the thing to remember is that these interactions are symmetrical. This, so we decided, CJ decided that opiate use was the moderator here and that pain was the moderator here. Ignacio, is there anything mathematically in this equation that says that those two have to be the moderator?
Actually, no. You are just testing if pain is the common moderator in each of the predictors.
Yeah. This is completely a 100% theory conceptual based question. Now, as you're putting these questions together, right? So, Alicia, I'm thinking about your thesis project that we're thinking about, right? And so the question is looking at PTSD and some type of sort of health wellness outcome, and thinking about daily hassles as an exacerbating factor, maybe strengthening or weakening that relationship. We could, in that example, just as easily look at whether or not daily hassles impact mental health and sort of wellness, and see whether or not PTSD severity changes that relation. Okay, we can look at this either way. There's nothing in here that says one has to be the moderator or the other one has to be the moderator. But what we want to do is be thinking about conceptually what makes the most sense. And in most of the time, we're going to have a situation where research has already established a clear link between these two variables, and what we're interested in is whether or not this other thing starts to change that relation. But there's no mathematical statistical reason you couldn't flip that interaction around and look at it differently. Okay? Does that make some sense? All right. So we're going to start so we've got two interactions. In this equation, we got a couple interaction effects. We're going to start by just looking at sort of a reduced model where we're just interested in whether or not opiate use influences the association of pain and functioning here. Okay. Now I had gone through, and who's here super up to speed on algebra and restructuring equations? Show of hands. All right, I'm flipping through screens. Sean maybe is sort of up to speed on algebra, and Chris M sort of up to speed on his algebra. What's up?
Let's do it.
All right. So what we want to do is, so with our model that we go through, we can go through and start manipulating this model, sort of using algebraic sort of principles to go through and see sort of these moderation effects. I posted a handout that sort of kind of walks you through this. Would very, very strongly recommend you go through and take a look at that just to kind of refresh yourself on this. Okay. So here we've got a reduced model, opiate use, pain, and then the interaction. Okay. And so what we're going to do is I'm going to start restructuring this equation so I can see explicitly the conditional effect of pain on functioning and how that's going to change within the context of opiate use. Okay. So what I'm going to do is I'm going to start by bringing down, if pain is my conditional effect, I'm going to bring down any effect that, or any term that doesn't include pain. Okay. So pain's my conditional effect. If I go up through and I take a look, that has pain in it, that has pain in it. But here I have my intercept and opiate use. No pain in there, right? So I'm going to drop that down. And then what I'm going to do is I'm going to say, okay, these remaining effects involve pain. So I'm going to take pain, bracket this off. And then what I'm going to do is I'm going to bring down these terms, right? So here I've got negative 10.05 pain. So I'm going to drop 10.05 pains out here. And then I got 4.60 times opiate use times pain. If I take 4.60 times opiate use, drop this down. Okay. Sean, is this a functionally mathematically equivalent equation to what we have up here?
Yes.
Yeah, it is, right? And so as you're going through, and I can't stress that it's enough, as you're going through and factoring these equations by hand, once you get to your factored equation, work backwards, multiply this out, and see if you get your original formula. If you don't, something's gone wrong somewhere in here. You'll screw this up. I screw this up. You'll make mistakes. Always, always, always double check. The number one take-home message with moderation is have fail-safes to go through and make sure that you haven't made an error somewhere. Okay. Questions on how we went through and factored that equation out? Okay. So what we can see here now within this equation is, so we have our intercept, we have our effect for opiate use, and then, Nick, so we've got a coefficient, so here for pain, and what does this coefficient for pain depend on?
It depends on opiate use.
It depends on what value we plug in here for opiate use, right? So here, if I say I'm looking at people who aren't taking opiates, and remember we centered opiate use so that people, our raw variable was 0, 1, and we have equal numbers of people taking opiates and not taking opiates. So when we center it, we get negative 0.5 as a value representing our people who don't take opiates, and 0.5 as our value for people who do take opiates. Ignacio, if I have an unbalanced design, is my centered variable for no opiates and not opiates, is it going to be 0.05 or 0.50? No, it's not. So just because it's a dichotomous variable doesn't mean your centered values are negative 0.5 and 0.5. It'll be sort of whatever they are, but just be careful with that. Okay. So for no opiates, I bring down my equation here. And so I've got 10.04 times minus 0.86 times opiate use. Well, I'm talking about people without opiates, so I'm going to put negative 0.5 plus 10.05 plus 4.60 opiate use. I'm talking about people without opiate use. Plug negative 0.5 in there times pain, right? And so if I run this out, I'm getting my new effect. So if we take this and multiply that, add all that together, and then multiply, add sort of all that together, I get a reduced equation that's 10.47 minus 12.35 pain. Okay. Alicia, what's my unique effective? My coefficient for my unique effective pain on roll functioning in this model?
Say that one more time.
Yeah. What's my coefficient for pain?
The 12.35.
Yeah, negative 12.35. Always, that's another thing too. Watch your signs. You'll get turned around there. So my coefficient for the unique effective pain on roll functioning for people not taking opiates is negative 12.35. Okay. So if I go now through and take a look at people who are taking opiates, okay, so I'm going to take my same equation, but this time I'm talking about people who are taking opiates. So instead of negative 0.5, I'm sort of putting in a value for people who are taking opiates. I'm going to switch that over to 0.5. And if I do that, now I've got 10.04, 0.86 times 0.5 minus 10.05 plus 4 is 0.60 times 0.5 pain. And if I run this out, Alicia, now what's my coefficient for the unique effect of pain on roll functioning for people who are taking opiates?
Negative 7.75.
Negative 7.75. Okay. Sean, what happened here?
That opiate use affects the slope of your dependent variable.
Exactly, right? Did this happen with our additive model?
No.
No, it couldn't, right? But here, because we've included our interaction term, now all of a sudden the unique effect of pain on role functioning is dependent by definition on opiate use. Okay. Now, this effect is always going to change to some degree, but this is what our statistical test tells us whether or not we have evidence for an interaction effect within these data. Okay. Questions about how we went through and factored this out? Yeah, Chris.
This just says that opiates are beneficial to role functioning, more beneficial than no opiates.
Well, we're going to go through and take a look at that and see, right? Because this is the question. For this data set, we've got people, and this was collected in early to, or sort of like the mid 2000s when we were doing this work, and they're handing out opiates like candy, right? And we're running a PTSD clinic and seeing people come in just stoned out of their mind, not because they were intentionally abusing, but just because they were taking medications that were prescribed by their doctor, right? And so the question is, if opiate use is functioning the way it should, we should see opiate use increase pain, but that's the question, right? Like what's going on here, right? So going through, taking a look at that. So people kind of see how we went through and factored out that model. Okay, so let's go through and take a look at the full model now. So that was just a reduced model. Do the same thing, but this time what we're doing, we've got two questions. What's the impact of pain severity on the relation between PTSD and role functioning? And what's the impact of opiate use on the relation of physical pain and role functioning? Okay, so we've got our full model, right? This is our full interaction model. And our two questions, we've got PTSD and functioning is our base relation. Pain and functioning here, our moderator is going to be pain for this effect and opiate use for this effect. Okay. So we're going to restructure our equation as before. So Nick, what are my two conditional effects of interest within this model?
So you're looking at the conditional effect of pain and opiate use.
Okay, so
But they're all different.
Okay, yeah. So I'm looking at a conditional effect of PTSD here and a conditional effect of, what's my other conditional effect?
Pain.
Pain, okay. So remember, our conditional effect is just our base relation that we're thinking is going to change depending on sort of the value of some other variable, right? So I've got a conditional effect of PTSD and pain. So what I'm going to do is I'm going to go through down and pull out everything that doesn't involve PTSD and pain. So I've got here my intercept, and then opiate use. That's not a conditional effect, at least how I'm conceptualizing this, correct? So I'm going to pull down opiate use. But now, all my other terms involve a conditional effect, right? So what I'm going to do is I'm going to go down through, as I was going to say, okay, here's my intercept, opiate use, but then I'm looking at conditional effect of pain, conditional effect of PTSD. So what I'm going to do first is I'm going to go through and gather my my terms that are involved in my conditional effect of pain. So I've got my coefficient for pain here, and I've got opiate use times pain, so I'm going to pull that down, factor that out. And then I'm going to say, all right, remaining is PTSD and pain times PTSD, that one, going to move those down. Okay. And so what I get is now a restructured equation. And when I'm looking at this, here it's kind of hard to see. But when I'm looking at my restructured equation, I can see that the effect, unique effect of pain on role functioning is dependent on opiate use, right? And the unique effect of PTSD on role functioning is dependent on pain, okay? And so what I'm doing now is I'm looking at the conditional effect of pain and PTSD, and I can start to see this a little bit better in my restructured model. People see how we went through and factored this out to make these effects more clear. Questions? What's that?
Do you not use the, because there's the pain and PTSD, but is that because you're looking at, because pain is the moderator and not the base that we're looking at?
Yep, exactly. Now, if I had decided that PTSD was my conditional effect for both of those, or excuse me, if pain was the conditional effect for both of these, then the restructuring would look a little bit different, right? And so this is why it starts to become very important that you have a good conceptual idea of what effect that you're expecting to see, and then work from there. Because otherwise you'll get kind of turned around with stuff.
This is for two different research questions.
Yep, these are two different research questions, right? So we've got, yep. So I'm running this within the same model, right? And this is kind of just for demonstration, but I've got two interaction effects here. And my thought is that PTSD impacts role functioning, but that may change depending on pain severity. And I think pain might impact role functioning, but that might impact opiate use. And if I really think that there's a three-way interaction, I could include those. And then there's an interaction of opiate use and PTSD that I could look at. But based on my question, this is the model I've elected to set up.
Okay, that makes sense. For a second, I thought we were just doing one question, and I was wondering why there were two.
Yep.
Moderation.
Yeah.
Okay, cool.
Questions? Okay. So what I can do now is I have my restructured equation, right? So I can see very clearly conditional effect of pain based on opiate use and PTSD on role functioning based on pain, okay? And once I've pulled this together, now what I can do is start looking at the simple slopes, okay? This is going to be the conditional effect of, here we're going to start out with pain and PTSD. What I'm going to do is I'm going to look at the conditional effect of PTSD on role functioning at high and low levels of pain. Now, what we typically do, and this is just tradition in psychology, is we generally will run these simple slopes at a standard deviation above the mean of our moderator, standard deviation below the mean of our moderator, right? Why might a standard deviation be a good sort of point to go through and take a look at conditional effects? Yeah, Chris? Yep.
It's easily understood when you publish across the literature.
Okay, yeah. Standard deviation makes sense, right? I understand where a standard deviation above and below is, right? Why not, Nick, why not 4 standard deviations?
Just thinking about what distributions look like, that would be quite extreme. You probably wouldn't detect anything, and just, thinking about interpreting them for populations. Yeah, it doesn't make a whole lot of sense to look at the simple slope or the conditional effect of X on Y at values of the moderator that don't exist in nature, right? It'll make it look super different. It's just not reasonable, right? And so technically and generally what we'll do is a standard deviation above and below is just kind of a nice point to go through and take a look and say, okay, at levels that we'll probably have observed, almost certainly we'll have observed in our data set, what's the unique effect of X on Y sort of at these two different points, okay? Questions about why we're setting this as standard deviation above and below. Okay. This is also another thing tomorrow, because we've centered our variables, right? What's the mean of pain in my sample? 0. And so what's a standard deviation above and below based on sort of the slide here?
1 and -1.
Okay. Now, not so our variable, we centered it, but it's not a z-score. So what's our based on this? What's our standard deviation?
1.34 and -1.34.
Yeah, right. So our standard deviation stays the same. I mean, this could easily be 5.86 and -5.86. But the nice thing with centering is it makes your simple slopes a little bit easier to calculate, because it's just plus or minus whatever your standard deviation is in your set, right? If we could do it with our uncentered solution, it would just mean that we would have to take a high pain would be whatever our mean was plus a standard deviation, and so that's 10.78, and negative, which is 5 point something, right? It starts to screw things around. Centering just makes it easier, okay? So we go through. So for high pain, if we go through and we take a look at, this is my factored equation that we did in the last step. Well, what I'm interested in here is looking at the unique effect of pain on outcome at high levels, high and low levels of pain, holding everything else constant at 0, right? So if I hold everything else constant at 0, if I plug 0 in for opiate use goes away, right? So those terms are now gone, right? CJ, what does it mean holding opiate use constant at 0?
Just won't be included in the slope for the model for this.
Yeah, okay. This starts to become important because here, and particularly because opiate use is part of a conditional, part of an interaction term. If I hadn't centered opiate use, what would 0 in terms of opiate use correspond to? CJ? For my raw metric, what did 0 correspond to in terms of opiate use? If it's 0, 1, what probably, if you had to guess, what would 0 mean for opiate use?
No opiate use.
Non-users, right? And so this is a tricky thing. So do I center my dichotomous variables? Well, I would make an argument that for interpretive purposes, for our overall effects, centering our dichotomous variables, true like dichotomous variables, makes some sense because now what I'm saying is just controlling for opiate use. If I'm using my raw 0, 1 variable for opiate use, holding opiate use constant at 0, I'm talking about people who are not using, right? And that's a different kind of group, right? But because I've centered this, holding opiate use constant at 0, does anybody in my set have a value of 0 for opiate use on my centered variable? Nope. There's no one has that value. It's just saying controlling for that, taking it out of the equation, and sort of moving forward. Okay. So when I center opiate use, I go through and drop that out. And so I'm left with 10.04 minus 10.05 times pain plus 0.17 pain, 0.19, right? Go through and do that. And then if we go down through and we say I'm wanting to look at the effect at high levels of pain, pain is 1.34. So we plug in, substitute that for our levels of pain, which gives me my simple slope for the unique effect of PTSD on role functioning at high levels of pain. Okay. People see where we got that? Okay. Same thing. If I go to low opiate use, or people with low pain, I'm doing the same thing, right? I can, I don't have to go all the way back up to the beginning. I can just start here because we zeroed out opiate use, right? But now I'm at 10.04 here, so to kind of dropping this back down. But this time what I'm going to do is I'm going to drop in high or low levels of pain, negative 1.34, right? Going through, setting that up, and now I've got my conditional effect of PTSD on role functioning at low levels of pain. So here, 0.04, this is the simple slope of PTSD conditioned at high pain severity, or the unique effect of PTSD on role functioning for at high levels of pain. Here, we have the conditional effect of PTSD on role functioning at low levels of pain. People see how we set this up. People seeing how the algebra works? Okay. This is a pain, and you're probably going to struggle with it initially, but this is an invaluable procedure for checking to make sure the results that you're getting out of your statistical models is correct. Everything should add up with this. Okay. Yeah, Chris?
Just a question, because we have our reference values of high and low pain set at standard deviation differences.
Mm-hmm.
We can transform PTSD scores into standard deviation PTSD scores and then use that to interpret standardized coefficient?
Good question. Good thought. Not here. Okay. We're just choosing a standard deviation above and a standard deviation below as points at which to look at the conditional effect. But there's nothing going on. I could set this to values of 2 and 2 and -2, or 0.5 and -0.5. And this is when we'll talk about this. One of the criticisms of this approach to probing moderation effects is that we're just kind of picking 2 semi-random points and looking at the conditional effect at each one of these. Now, conceptually, practically, these are probably better than many other points we can look at, but it doesn't give us the full range, and that's one of the limitations of this approach that you'll hear. Okay. All right. So we've got our simple slope for PTSD at high and low levels of pain. Okay. But we've also got another interaction here of opiate use and pain, and we're interested in looking at the unique effect of pain on role functioning for people who are and who aren't using. Okay, but we can do this the same way as before. So here's our full restructured equation, right? And I'm looking at the unique effect of pain at high level levels of opiate use. So anything involving PTSD goes away because we're holding PTSD constant at 0. Sean, what does it mean if I'm holding PTSD constant at 0 in my centered model?
You're holding it at the average.
Holding it at the sample average, right? So that goes away. So now I'm left with my constant, effective opiate, and then my interaction. And now what I just do is for my centered variable, -0.5 reflects people who aren't using opiates. People who are using opiates reflected at 0.5. And so if this is no opiate use, put -0.5 in, substitute that in for opiate use, which is going to give me my simple slope of pain on functioning for individuals not using opiate medications. Same thing if I take this for opiate use, start here, right? Drop that in, pop in, again, substitute values of 0.5, going to represent people who are using opiate use. For opiate use there, go down through, it's going to give me my simple slope for the unique effect of pain on role functioning for people who are using opiates. Okay. So here, Nick, help me out. Based on these effects, what if I'm looking at PTSD? What does it look like? How does the unique effect of PTSD on role functioning differ at high and low levels of pain?
So it differs to the extent that it's more, I guess, impacted at low levels of pain when looking at the absolute value of the coefficient. The slope's going to be steeper.
Yep. And what else? So this is a negative coefficient. What's this coefficient?
That's a positive one.
Right. And so the absolute value changes in direction, right? But it looks like, based on this, if this interaction between PTSD and pain were, if I had evidence for this interaction, I would say these simple slopes tell me that it looks like the unique effect of PTSD on role functioning is stronger for people with low levels of pain than it is for people with high levels of pain. Okay. And what about, Nick, what are we seeing for the conditional effect of pain on role functioning for people using and not using opiates?
So for this one, it's stronger for those who aren't, and the direction of the slope is both negative.
Yeah. Okay. So what we've done here is we've gone through and looked at the conditional effect of looked at our conditional effects at high and low levels of our moderator. Now we've selected for our continuous moderator, standard deviation above and below. For people, for our dichotomous, this shouldn't be plus or 1 standard deviation. This should just be reference values for no use and use, so scratch that. But again, what we're seeing here is conditional effects for my 2 different groups. Okay. Now, note that if holding PTSD constant at the mean is fine as long as we don't have a 3-way interaction, right? If PTSD then moderates the interaction of opiate use and pain, which we would need a three-way interaction. Then we've got a three-way interaction that exists in the world, but we haven't modeled it. And then that's going to be a misspecification error, right? So you want to be careful about nothing says that when you're putting these models together that you have to have a completely factorial design with all possible interaction between all possible variables. But note that if those interactions are there and strong, and if you don't model them in, then you've got a misspecification error, and then we're concerned about bias in your estimates and things. Okay. All right. And then what we can do is we can now go through, and in our graphs we can plot these simple slopes. Okay. So here is my interaction of opiate use and pain. As Nick noted, we're seeing reductions or negative. So as pain increases, role functioning decreases, right? But it looks like the strength of that relation looks to be stronger for people who aren't using medications as opposed to people who are. Okay. Alicia, do we have evidence that the magnitude of these slopes are different?
Yes, because the numbers are different.
Okay, so the numbers are different. But do I have statistical evidence that these, because they look pretty similar, right? Do I have evidence that this is evidence for sort of a true difference here, or could this just be static? It could be, but what did I find that gives me maybe some confidence that that the slope, my best guess that the population, the slope and the conditional effect in the population is different for people who aren't using opiates versus those who are. Anybody help her out? Why did I run these simple slopes in the first place?
They represent an interaction effect similar to what we had talked about last semester, so you can see that they crossed.
Okay, so we'd see that they'd crossed, right? But also, if I find particularly very compelling evidence of an interaction of opiate use and pain in my regression model, that tells me that yes, in fact, I have strong evidence that these are different from one another, right? And again, that omnibus interaction, this is what's telling me that even though these look to be generally similar, that if that interaction effect is sort of, if I've got evidence for this interaction term, then that says yes, that it does look like, based on the data that I've collected, that the association between pain and role functioning does in fact depend on whether or not people are using or not using opiates. Okay, so it goes back to that interaction term. If I find strong evidence for an interaction in my overall model, it's saying that, I have pretty compelling evidence that this does differ, right? And so, particularly given the dichotomous nature of my moderator here, I can reasonably claim, we have evidence that these two slopes are different than one another, and that it's not just static. Okay, so this is just going back to that interaction term.
Josh, are you comparing the t-value on that interaction term? Is that what you're referring to?
Yeah, the statistical test of that interaction term.
Okay.
Yep. Okay, and then same thing for pain and PTSD. Much different. This is much clearer sort of thing going on here, right? Looks like based on my model, absolute value for my slope for PTSD and role functioning, like a slight positive association. So as PTSD increases, functioning increases, which seems strange, but that's what it's saying. But then at low levels of pain, a strong negative relation between PTSD and role functioning. As PTSD gets stronger, role functioning decreases. Okay. People seeing how we went through and created these. So basically what I did here is in Excel, I took my conditional effect, or my equation for no use, and plugged high and low levels of pain in. My conditional effect for use, High and low levels of pain, gave me that to plot out. Same thing, pain and PTSD, took my equation for low pain, high and low levels of PTSD, high pain, high and low levels of PTSD, gives me the plot we're seeing here. Questions? All right. Someone with a good eye. Anything problematic with these simple slopes? Tomorrow, what's my outcome variable here? Row functioning, yeah. And what's the range? What's the real range of row functioning? Yeah, not negative, right? And so this is another thing to be careful of, right? So we can have model predicted values of an outcome that don't actually fall within that outcome, right? So here at high levels of pain, we're getting negative values for row functioning, which don't exist, right? Here, my effect of PTSD, my conditional effect of PTSD on row functioning at high and low levels of pain are all negative, and that doesn't exist, right? So again, this is a function of having kind of a funky outcome variable. And so just wanting to go through, this doesn't necessarily negate our interpretation of what's going on, but we need to be careful and thoughtful when we're plotting this out and thinking, does this make sense? Okay. Questions on any of this?
Would you consider adjusting your plus or minus 1 standard deviation so that the values move up into real range?
You could do that, or if I was plotting it, I would just cut off the plot at 0 and just say that's kind of where it was. So okay, so when we're plotting our simple slopes in Excel, we're just going through and creating a 2x2 contingency table, and so you can go through and follow these directions here. This is what this looks like, right? So what I've done here for my PTSD by pain interaction, so at low pain, I'm looking at my conditional effect of pain, my conditional effect of pain, or a conditional effect of PTSD at low levels of pain and high PTSD, right? And so we're just basically taking my equations here and plugging them in and creating values that I can then plot in Excel, okay? And so you see here, I've got the same equation for low pain, 23.51 minus 0.42, and then I'm just substituting high and low levels, a standard deviation above, standard deviation below for PTSD. Same thing, equation for high pain, negative 0.3, negative 3.43 plus 0.04, high and low levels of PTSD. Same thing, no opiates, levels of pain, opiates, right? And if I go down through, this can help go through and set up these graphs. Okay. Questions about that? Okay. All right. So this is what that looks like. Let's go through. We went longer than we typically do. Let's take 10 and come back at, let's say, 3:40. Cool. Cool. All right. Back to lecture stuff. People have questions about what's going on with these multiplicative models and how we're sort of going through, looking, sort of testing these interactions. Okay, cool. So let's go through, jump back in. Okay, and so this is just a screenshot of sort of the stuff that I was running there. You can go through and take a look to make sure you understand how we're going through and modeling these or plotting these interactions. Again, always, anytime you find an interaction effect, what's the first thing you do? Plot it. Always plot it to see kind of what's happening with this. Okay. Plot it. Okay. So if I go through and I factor my simple slopes, I can find absolute values for my conditional effects. I can go through and plot at high, low levels. My evidence of non-zero interaction terms in my output. Okay, so Sean, this is what you were talking about. If I find that interaction term has a small p-value, suggesting that it's providing evidence for a unique effect of x on y that changes over values of my moderator. Okay, that says that, yep, this conditional effect does change across levels of my third variable. But what this doesn't do is it doesn't provide any test for whether or not my specific conditional effects at a standard deviation above or a standard deviation below, if I have evidence for an effect there, right? So, for example, if I take a look here at my simple slopes for effective PTSD and functioning at high levels of pain, I've got something that looks like a strong negative effect here that's probably obviously not zero, right? But I've also got this effect here that, again, someone noted here, it looks like I got a positive association, and the absolute value of my conditional effect, my simple slope at high pain, is positive, suggesting that as my PTSD symptoms increase, my role functioning increases, right? Now, this is weird because if that's an actual effect, then I'm having a hard time understanding why that might be, right? But it's also possible that positive point estimate for the conditional effect that I'm finding is just random variability. It's just noise, right? So what I need to go through, I can get my simple slopes and I can get my specific conditional effects at high and low levels of my moderator without doing anything. All I need is my overall model. But if I want to go through and test the unique association of x on y at different levels of m, I need to have a different strategy to run through those hypothesis tests. Okay. And so what I can do is I'm going to go through and modify my overall model in a couple of different ways to kind of trick SPSS into giving me a test of the specific effect of my of x on y at different levels of x or different levels of m. So if I'm starting out and I want to know what's the impact of pain severity on the relation between PTSD and role functioning, okay? So CJ, what's my conditional effect here?
The conditional effect of PTSD on role functioning is that it's pain severity. Sorry.
Okay, so yeah, my conditional effect is PTSD severity. PTSD, looking at conditional effect of PTSD, and what's my moderator? Pain severity. Okay. So what I'm going to do is I'm going to go through and I'm going to rescale my moderator, and I'm going to create two new variables in SPSS. One variable is going to correspond to high levels of my moderator. Other variable is going to correspond to low levels of my moderator. So for high pain, what I'm going to do is I'm going to set high pain equal to my centered pain variable minus a standard deviation. And for my low pain, I'm going to take that and set that equal to pain plus a standard deviation. So my high levels of pain are recentered at a standard deviation below the mean. And my low levels of pain standard deviation are centered at a standard deviation above the mean. Does this make sense to people? Well, it's actually kind of counterintuitive, right? Because if I want to look at high levels of pain, it feels like I should be adding a standard deviation to look at high levels of pain, right? And if I want to look at low levels of pain, it feels like I should be subtracting a standard deviation. But it's actually, it flips around, okay? So what's going on? If we take a look at our variable here, so this is our centered, let's say our centered pain variable. Okay. Tomorrow, what value in my centered pain variable corresponds to average levels? 0. Okay. So if I take this and I then go through and subtract a standard deviation from all scores in the distribution, right? Where is my mean now? If my mean was 0 and I subtract a standard deviation from all values in the set, what's my new mean here? Yeah, negative 1.34, or in my graphic here, negative 2.3, right? So my new mean, it was 0 with my centered. But then if I subtract a standard deviation from all values in the set, my new mean is whatever the standard deviation is, okay? Tomorrow, where's 0 now in this distribution? Yeah, it corresponds to a standard deviation above the mean, right? So if I go through with my centered pain variable and I subtract a standard deviation from every value in that set, my new mean is sort of minus whatever the standard deviation is, and my 0 value represents a higher value of pain than the mean, okay? And why is this important within the context of regression? Why is 0 important within the context of this model? Ignacio?
That's exactly the question. I don't know.
Yeah. Can someone help us out? Why are we so fixated and sort of interested in 0 as a value within the context of regression? Exactly. If I'm holding everything constant at 0 and I'm holding pain constant at 0, what does that mean for my high pain variable?
That it's constantly higher than the average.
That I'm holding it constant at high levels of pain, right? And if I do the same thing, if I take that centered variable and I add a standard deviation to every value in the set, I go through and I do that, and so now my mean was 0, but now my mean in my distribution is 2.3. Where does 0 fall? Below the mean, right? And if I'm holding everything in my model constant at equal to 0, it means I'm holding things constant at low levels of pain. Okay, so this is what we're going to do. We're going to go through and we're going to play around with scaling. Hold on real quick. In order to test the unique effect of x on y holding all other variables constant at 0, what we're going to do is we're going to start playing around with what 0 means. And so this starts to become important when we're going through and we're interpreting individual effects within our regression model. Our unique effects are always interpreted as the unique effect of x on y when all other variables are held constant at 0. Okay. Now in my additive models, does it matter what other variables are held constant at 0? Not really, because I can switch those around. My unique effect of x on y is going to be the same no matter what the other variables are held constant at, right? But for our moderation variables, if we've got a variable that's involved in an interaction term, particularly a strong interaction term, now all of a sudden where 0 is starts to make a big difference. Okay, so if we do this, and I'm going to go through, and what I'm going to do for this, I want to look at the simple slope and the conditional effect of x on y at high and low levels of pain. And so what I'm going to do is I'm going to create a new variable called high pain by subtracting a standard deviation from everything. Another variable called low pain, adding a standard deviation to anything. And then what I'm going to do is I'm going to create 2 new interaction terms that correspond to those conditional values of my moderator. I'm going to have a high pain by PTSD interaction. And this is going to be high pain times my centered PTSD. I'm going to have low pain times PTSD. This is low pain times PTSD. And then what I'm going to do is I'm going to run a separate regression model for each one of these revised levels of my moderator. So my first model is going to be, I'm going to include low pain, opiate use, PTSD, opiate times low pain, and low pain times PTSD. So basically what I did, I'm running the same model, but instead of center pain, I'm substituting high or low pain and the interaction of low pain and PTSD in sort of this equation. Okay. And when I'm looking at this, my conditional effect for PTSD now represents the unique effect of PTSD and functioning at low levels of pain. And then if I run a second model, substituting high pain and high pain interactions for everywhere we would have had pain, my conditional effect now represents the unique effect of PTSD and functioning at high levels of pain. People see what we're doing here? Okay. So what we're doing is overall, we found an interaction and looking at if this is my model, okay, and I've got let's say I have evidence of an interaction of opiate use in pain and PTSD in pain, okay, and so I know that this is a conditional effect and this is a conditional effect, okay. Sean, if I'm looking at the unique effect of pain on role functioning, what is this value of pain represent?
It's the slope holding, if you were to hold all other predictors constant at 0.
Right. And so if pain is conditional on opiate use, right? So it means the effect of pain on role functioning controlling for opiate use, right? What about this one? So I've got a conditional effect of pain and PTSD. So this is effect of PTSD on role functioning when what?
When opiate use and PTSD are held at 0.
Well, opiate use and pain.
Oh, and pain. Sorry.
Right. And what does it mean in my centered model when pain is held constant at 0?
You're at the average.
Yeah. So in the presence of this interaction, what this is saying is this is a conditional effect of PTSD on role functioning at what levels of opiate use? Or what levels of pain?
Oh, at the average.
At average levels of pain. Okay. And so this is why when we're interpreting our specific effects with these multiplicative models, it's very, very, very important to understand what 0 means. So right here, what I've got is a unique effect of PTSD on role functioning at average levels of pain, right? But if I wanted to find out what the unique effect of PTSD on role functioning was for high levels of pain, well, if I just put 0 to be corresponding to high levels of pain, now all of a sudden my conditional effect here reflects the unique effect of PTSD on role functioning at high levels of pain, right? And if I recenter pain so that my pain predictor in here reflects 0 reflects low levels, then this is going to change. And it's going to give me my unique effect of PTSD on role functioning at low levels of pain, right? So all we're doing is we're playing around in SPSS. If we change around where that 0 point is, it's going to change what our conditional effect pops up as. Okay, so if we go through and we've gone through recentered, looked at interaction terms. So here with my additive model, here's my centered solution, my uncentered solution. My R squared is the same. My coefficients outside of my intercept are identical, right? So my effect of pain, opiate use, and PTSD is identical in my centered solution versus my uncentered solution. What's the only coefficient that changes here? What do you think, Chrissy?
Does the constant count?
Yeah, the constant does count. And why does the constant change across these models?
Because the constant is supposed to tell us where or what the score would be if everything is held to 0, and if we change where 0 is, then the constant's going to change.
Exactly. So in my uncentered solution, or excuse me, in my centered solution, my expected value for role functioning, controlling for opiate use, with pain and PTSD held constant at the mean, is 67.5. But in my uncentered solution, my expected value for role functioning at 0 pain and 0 PTSD, oh, I got these flipped around. Oops. So this is my centered solution, this is my uncentered solution. So swap that around. But in my so on my uncentered solution, my expected value for role functioning when for people not using opiates, because opiate use is 0, who have 0 levels of pain and 0 levels for PTSD, is 67.46, right? So reasonably high levels of functioning expected for people who have a score of 0 on pain, 0 on PTSD, and who aren't using opiates, right? But if I switch over here to my centered solution, this is my expected value of my outcome. This is expected value of role functioning, controlling for opiate use, holding pain and PTSD constant at the mean, right? Now all of a sudden, I've got a lower level of expected functioning because I've got a group of individuals with relatively high levels of pain and PTSD, and so holding those constant at average is a very different thing than having 0 scores on these, right? So we're seeing things move around a bit. Are people seeing sort of how this is working? Okay.
Question.
Yeah.
Josh, if we go back to the previous slide.
Yeah, this one.
With the interaction terms, are we actually computing those?
Yep. In SPSS, you're actually computing those. Yep. So those will be real columns and variables in your model, and we'll walk through how to go through and do that. Okay. All right. Now, if we're looking at uncentered and centered solutions in your multiplicative models, however, now things are going to start changing a little bit. We'll see in your model summary, R squared identical, because centering doesn't change sort of the overall sort of piece of the pie that's being picked up. But what we do start to see is changes in your coefficients. Okay, so here we're seeing differences in your intercept, which is what we had saw before. But now we're seeing changes in your pain severity score across your centered and uncentered solutions. We're seeing changes in opiate use across centered and uncentered solutions, and changes in conditional effect of PTSD across centered and uncentered solutions. Okay. Why are we seeing differences in our conditional effects across our centered and uncentered solutions when we didn't see that with the additive models? So if I go through and I take a look at let's take a look at my centered solution. Chris M., am I seeing evidence for interaction effects of opiate use and pain and pain and PTSD?
Yes, it appears that you are.
Yes, it looks like I might have some evidence there, right? And so within the context of my interaction, this is saying that the effect of pain severity on role functioning is dependent on opiate use. And this is saying that the effect of PTSD on role functioning is dependent on pain, right? So here, that means that, so if I start switching around where that zero value is, now all of a sudden, because all of these are conditional effects, pain, opiate use, and PTSD are all dependent on one another. And so depending on where we set that 0 point, these are all going to start jumping around across my centered and my uncentered variables. Okay. Alicia, what effects aren't changing, or what coefficients aren't changing across these two models?
The bottom two, I'm not sure what that is, by pain and pain by PTSD.
Yeah, my interaction terms aren't changing. So in these models, your highest order interaction term is not going to change. It's going to be the same no matter where you center your variables. So my coefficients for my interaction terms, those are identical. The p-values are identical. The test statistics are identical. Those stay the same, but everything else starts jumping around. Okay. Other thing that we start to see in my uncentered solution, if I look at my collinearity diagnostics, right? We're seeing tolerance values of 0.13, 0.07, 0.1, 0.06, 0.05, VIFs of 7, 13, 9.5, 16, 18.5. Anybody remember if that's good or bad? Yeah, that's bad, right? That's suggesting massive, massive intercorrelations among my variables. Chris, see what happens in my centered solution.
You are not seeing any of that.
Right. And so this is what's been expressed and noted as a benefit of centering, is that if I had predictors that were completely uncorrelated, because my covariance starts to be determined in part by means, and if I recenter the means to be 0 to everything, if I have predictors that are completely uncentered with one another, if I go through and center all my variables and then create interactions with my centered variables, my correlations between all my variables will continue to be 0. Now, if I have intercorrelated variables, I'll continue to get some relation in between my predictors. What it does is it takes something that would be normally something that we would be very, very concerned about, collinearity, and it completely wipes it out when we center our variables. Okay. Now, for OLS regression, the collinearity that we get here gets washed out by sort of some other factors. So in OLS regression, when we're talking about multiplicative terms, it really has no real impact on your hypothesis tests. Okay, but if you were to go through and try and run these analyses in with a maximum likelihood, like in an SEM type of thing, you'd start to get weird problems with inversion of matrices and things like that would be problematic. Okay, so traditionally, reduction in collinearity has been cited as a benefit of centering. For OLS regression, yeah, it does. It definitely makes our collinearity statistics look better. It doesn't actually have a practical impact on the model, but what centering does do is it makes interpretation much easier, and so generally always good to center your predictors. You don't center your outcome. Don't center your outcome, but center your predictors and sort of work from there. Okay. And here we see standardized coefficients are crossed out. That's because your standardized coefficients are problematic. We'll talk about that in a bit, but don't want to interpret your standardized coefficients specifically for your interaction terms that are provided in your SPSS output. All right. So looking at my correlations, again, in my centered and my uncentered variables, my correlations between my individual predictors are all not changed when I'm looking at centered and uncentered, but you'll see much, much higher interactions here in my with my interaction terms in my uncentered solution versus centered interactions here. All right, and finally, so this is going to be my full model. Here I have centered pain, centered opiate use, centered PTSD, and then my interaction of opiate use and pain and PTSD, and pain and PTSD. Okay. Here is my simple slopes model for low pain. So here I have low pain, centered opiate use, centered PTSD, low pain and PTSD, low pain and opiate use. Okay. Here, high pain, I got high pain, centered opiate use, centered PTSD, high pain and PTSD, high pain and opiate use. Always important when you're going through taking, this is maybe one of the most important slides in this entire deck, is because this is what you should be using to determine whether or not you've done this correctly, okay, you're going to see if I'm looking at, so my conditional effect, I'm looking at a conditional effect of PTSD and functioning at high and low levels of pain, okay? What I should see when I take a look at my interaction terms are identical across these three models. Your highest order interaction terms won't change. Now, if you had a three-way interaction, your three-way interaction would change, your three-way interaction would be identical. Your two-way interactions would jump around. But here, because your two-way interactions are the highest order terms, those are going to be identical no matter what you've done with your centering. If those change, you've done something wrong. Okay. You'll also see that your moderator, right? Pain is your moderator here. Your coefficient for pain doesn't change across these. Okay. But your constant and your conditional effect of opiate use and conditional effect of PTSD, these are both variables that are involved in an interaction with pain. Those are going to jump around. Okay. But when I'm going through and I'm running this, right, my question was, what is the conditional effect of PTSD and high and low levels of pain? If I look here, Nick, what's my conditional effect of PTSD on role functioning at low levels of pain?
You mean like what's the coefficient? It's negative 0.4013.
0.4013. And what is do I have evidence for an effect here?
You do.
I do. Okay. And what about my coefficient at what's my conditional effect of PTSD at high levels of pain?
The coefficient's very small, 0.043, and there's no support for an effect of that.
Okay, right. So my coefficients. So this is the effect of PTSD on functioning at low levels of pain, specifically a standard deviation below the mean. This is the effect of PTSD and role functioning at high levels of pain, standard deviation above, right? But here, this is a clarification. Strong evidence of a unique association of PTSD and role functioning at low levels of pain. But here, at high levels of pain, I don't have much going on, right? So the absolute value of this coefficient is positive, but this looks like that's just all noise, right? So there's nothing really to mention about that. Okay. And then here, if I go through and compare this with the conditional effect of PTSD on role functioning for this full model, Nick, what does this conditional effect represent?
It represents when holding all other variables constant at the mean.
Uh-huh. And so what does that mean for pain?
That it's impacted by PTSD.
Okay, so this is a conditional effect of PTSD on role functioning when pain is
controlled for
at the mean. Okay, so this is where it starts to become important to recognize always within your regression models, what does zero mean? And then using that when you're going through and interpreting these individual effects. For our additive models, holding it at 0 or 1 billion, I don't know. It doesn't matter because it doesn't change your unique effects. But as soon as you have multiplicative terms, now all of a sudden where that zero, where your scale is centered, where the 0 point on that scale starts to make a big, big difference. Okay. Circle this slide, put it under your pillow, tattoo it on your back. These models, you'll screw them up again and again. I still screw these up because small differences, small changes will start to throw things off. But you can always check to see if you've done something right by looking at your full model, your low and your high levels. And if things map out consistently the way they're supposed to, you know you've done it correctly. If they don't, you've made an error somewhere. You need to go back through and take a look. Okay. So here, this is what we've got in SPSS. We've got a conditional effect of PTSD at low levels of pain at negative 0.41, high levels 0.043. If we go back through and see what we got when we This is what we did. This is our conditional effect at high and low levels of pain when we factored this by hand. What are we getting? So what's a conditional effect of PTSD at high pain?
You would get simple slope?
Yep. So this is my simple slope. So what is my simple slope for PTSD at high levels of pain?
The coefficient B.
Yep.
So
And what's the value?
0.04.
0.04. And what's my simple slope from factoring this at low levels of pain?
0.42.
0.42, right? So this is what I went through and factored by hand just using my overall model. When I go through and I run this in SPSS, actually sort of going through and recalculating everything, conditional effect, 0.41, 0.42, it's the same within rounding error. 0.04, it's the same here. This is just a nice way to go through and make sure everything squares up, because you'll get it wrong. You'll forget a sign or something like that, and things will be off. There's just so many different things that can go backwards with this that it's always, always, always important to double, triple check to make everything pans out. If things aren't corresponding to the way sort of this pattern that should pan out, it means you've got an error in there somewhere. Okay.
Josh, I have a question.
Yeah.
So on the interaction terms in the high and low pain, are they really distributed T, or are they closer to like a chi-squared or something?
Yeah. With these are just observed values. These are used as predictors just like any other predictors. And
I mean like the last two, the high pain PTSD, can you use a T-test on those?
Yeah. That the distribution for these effects, it works out. So that's completely. So this is all completely legit. This all sort of works out the way it's supposed to. What we're doing in SPSS is we're just going through and creating that multiplicative variable. You can think about this, and we'll talk about this in a moment. You can think about this as the same as a transform, right? What if I had a natural log variable? Could I run that on a T distribution? Yeah. If I had a square root transform, could I use that? Yeah. SPSS, all SPSS is doing is just reading this as a variable and just looking at the effect. So, I think your head's in the right space, like trying to think about like, oh, is this going to be distributed? But remember that what we're looking at here is a sampling distribution of this coefficient. And so if I were to run this model 1,000 times with replication, with replacement, what I would get for that interaction term is I would still get the same thing. There's other stuff when we get into indirect effects that's problematic. But this, because we're just multiplying two variables together, your T distribution works. Okay. Yeah. We'll touch base with me later, and we can talk a little bit more about sort of distribution of that. Okay. Other questions? Okay, cool. So this is how we're going through getting our coefficients for our unstandardized solution. But what we see here, I went through and I crossed out our standardized coefficients for each one of these. That's because the standardized coefficients that SPSS gives us for our interaction terms is not correct. Okay. What ends up happening when SPSS gives you these standardized coefficients? All SPSS is doing is SPSS is taking all of your variables in your model and just converting them to z-scores. And then it's just taking the z-score of your outcome, regressing it onto the z-score of all your predictors, and then what you end up with is the unstandardized coefficient in that z-score model ends up being listed as your standardized coefficient here. Okay, so again, Chris C., how do I interpret this standardized coefficient for pain in this model right here?
You take your, or so it's what standard deviations away
Yep.
from
So for every,
zero?
yeah, so for every what?
Okay, so for every change or 1 point change in what are we measuring again?
Pain?
Pain. That's right. Sorry. Well, is that our dependent here?
Okay, so role functioning is our outcome.
Okay. So every 1 point change in role functioning. No, wait. Every 1 point change in pain, role functioning decreases by about half standard deviation.
Okay, almost perfect. What did Chris miss in there?
Both talking about both variables in terms of standard deviation.
Yeah.
units.
Yeah. So technically, technically, Chris.
1 standard deviation to half standard deviation.
Yep.
Got it.
Yep. And with your standardized variable, a 1 unit increase is a standard deviation unit increase, not a 1 unit increase, right? So here, my unstandardized coefficient, I would say this model is suggesting that at least my conditional effect of pain here, when everything else held constant at the mean, I'm saying a unit increase in pain is expected to result in about a 10-point decrease in role functioning. But my standardized coefficient says for every standard deviation unit increase in pain, I expect about a little over a half standard deviation decrease in role functioning. Okay, and so what's happening here is that all SPSS is doing to give you these things is that it's just going through and it's saying it's what's going on in the background is we've got z-scores for your outcome, z-scores for all your predictors, and then the unstandardized coefficients in that model just get plugged in here. Okay, but the problem is what you've done in SPSS is you've created a multiplicative, an actual variable that's opiate use times pain and PTSD times pain. And if I take, and what's important in order to run these models, I need to be able to factor these out, right? But I can't do that because the z-score of opiate use times pain, that number, is not equal to the z-score of opiate use times the z-score of pain. And the z-score of my value for pain times PTSD doesn't equal the z-score of pain times the z-score of PTSD. Okay? And so because of that, because I can't take these coefficients and factor them out the same way I was able to do here, these coefficients are not appropriate. Okay? So for my multiplicative models, for my moderation models, if I want to go through and present standardized coefficients for my interaction terms, which I will want to do, what I need to do is I need to go through and create a new model where I go through and I take a z-score of my outcome, z-score of my 3 predictors, and then create new interaction terms that's the z-score of my 2 variables, z-score of my 2 variables. And then I can go through and run that model with just all the z-scores. And now my unstandardized coefficients in my z-score solution will be my proper standardized coefficients for my 2 interactions. Okay? Because I can go through and I can factor this out. I can't factor out the z-score of that multiplicative effect. Okay? So just be aware when we're going through, and because you'll want to report standardized coefficients, just know that the standardized coefficients that you get for your interaction effects in SPSS aren't going to be appropriate. They're going to be off, and probably no one who ever reviews your paper, unless it's me, is probably going to catch that. But it's science last time I checked, and we probably ought to do it right as opposed to just doing whatever. And so wanting to go through and make sure that you're noting that. Okay. Questions? All right. We could, okay, we've got about a half hour left. Do you guys want to start jumping into an example of this? Let's do that. We probably won't get all the way through, but what we can do is we can start walking through an example in actual data to try and help consolidate some of this stuff. Okay. So what I've got here is I've got our regression data set that we've been working on for a while. Okay. And the handout that we're going to be working with here is going to be just our moderation analysis. Okay. So here we're going to run the same model that we walked through in lecture. We're just going to do it actually in SPSS code so you can kind of see this process. So what we're going to do is we're going to regress role functioning. We're going to drop the natural log just to simplify things. But we're going to regress role functioning onto PTSD, pain, opiate use, and then the interaction of PTSD and pain and opiate use here. Okay. So what I'm going to do is I'm going to start by centering my variables. So I'm going to go descriptives. Oops. Got pain, opiate use, and PTSD. Okay. All right. So I'm going to go through and run this. All right. And so what I'm going to do, create some centered variables here. So I'm going to go compute, and we'll call this centered pain equals pain minus 4.0702. Okay. And then I'm going to do the same thing for opiate use and PTSD. So I'm going to have opiate use, PTSD, and here, looks like it's giving me the mean, 0.5, mean here, 50.9303. Okay. All right. So what I'm doing, Chris M., why am I going through and doing this?
You're trying to get those centered values, aren't you?
Right. So we want this, and what this is going to do is it's going to turn the mean. If I go down through and I take a look here. So what I've done is I've created 3 new variables. I've got my centered pain, centered opiate use, centered PTSD. So my centered pain values, everybody who, kind of a variety. Here with my opiate use, people who aren't using now have a value of negative 0.5. People who do use medications, a value of 0.5, right? Everything's looking good. But what you should always do is always go through, once you've created your centered variables, check them to make sure that you haven't made an error somewhere in this, right? So I'm going to go through and I'm going to look at centered pain, centered opiate, centered PTSD. Okay. And if I go down through and I take a look at my output, if I'm looking at the mean values, I'm exactly 0 for pain, exactly 0 for PTSD. I'm a little off on my opiate use. That's just because it's not exact, a 50-50 split, but we're close enough here, okay? If you're not seeing zeros in the mean of your centered variables, you've gone haywire somewhere, so always make sure to check that, okay? And so then what we could do is we can go through and analyze. If I go regression, and I'm looking at role functioning, and if I were to look at pain, opiate use, and PTSD, statistics, part and partial correlations, and confidence intervals. Okay. So if I go through and I run this, that's just my, what I've got here is just my uncentered model. But then if I copy this in, and this time I have my predictors, my centered predictors. Remember, you don't center your outcome variable. You don't need to center your outcome variable. But if I run my regression with my centered predictors, right, we'll see that my R squared in my uncentered 0.376, 0.376. My F for my model is 39.63, 39.63. My coefficients 10.70, negative 0.685, 0.230, negative 10.707, negative 0.685, negative 2.30. It's all saying the same. My constant changes a little bit, but nothing gets turned around in my coefficients here. Okay. People following that? Okay. But Ignacio, I'm not interested in looking at first order effects. What am I interested in looking at? Yeah, I want to look at my interactions. Okay. So in SPSS, what we're going to do is we're going to go through and actually calculate these interaction terms. Okay. And so, Sean, this is where what we're doing is we're just creating a new variable that's a product function of two other variables I have in the model, right? So what I'm going to do is I'm going to go compute, and then I'm going to say, we'll call this op times pain is equal to centered pain times centered opiate use. Period. Okay. And then I'm going to do the same thing. Someone tell me what my other interaction is?
Pain and PTSD.
Yep. Pain, PTSD. Okay. So I'm going to do pain, centered PTSD. Okay. I'm going to run this. And if I go through and take a look at my data, now I have centered pain, centered opiate use, centered PTSD. And then I have interaction of opiate use and pain and opiate use and PTSD that are just literal variables in my model. Okay. Tomorrow you had a question. You kind of see what we got here?
Yeah.
Okay, cool. And so what we've done here is we've gone through and we've created our interaction terms. CJ, now what do we do?
You do another regression with these guys.
Perfect, right? So what I can do, because I'm lazy and I don't want to keep running through the menu, I'm going to copy that interaction statement, or that regression statement here. And so now I'm going to regress role functioning onto centered pain, centered opiate use, centered PTSD. But then I'm also going to put in opiate use times pain and pain times PTSD. Okay. People following me here? Okay. So if I go through and I run this, I'm going to get my model here, and this should look familiar. If I'm going through, I'm saying that it looks like, based on these data, the best linear combination of pain, opiate use, PTSD, and the interaction of opiate use and pain and PTSD is accounting for 42.6% of the total variability in role functioning in these data. My ANOVA table here is testing whether or not that R squared value is equal to 0, and it seems like that is a highly implausible hypothesis, right? So we have very, very strong evidence that the best linear combination of predictors in this model is accounting for some variability variability in my row functioning. If I go down through and I take a look at my effects here, what I'm seeing is my expected value of row functioning controlling for opiate use when pain and PTSD are held constant at the mean. If I jump down through and it looks like I have fairly good evidence against the null hypothesis of no interaction of pain and PTSD here, right? So I've got a decent, a reasonably small p-value. This is pretty marginal in terms of evidence, but it looks like there might be a signal there, right? But what I've got there, because opiate use, are there any first order effects, Ignacio, that aren't involved in some interaction effect?
First order effects?
Yeah, so these base effects. Are any of those not involved in an interaction?
They are involved, right? Because you use them to come up with interaction.
Exactly. So if we're assuming we have evidence for an interactive effect, what are all of these coefficients here, Tamara? What kind of effects?
Conditional.
These are all conditional effects, right? In the presence of this interaction says that the effect of pain on row functioning is dependent on opiate use, or conversely, the effect of opiate use on row functioning is dependent on pain. This is saying the effect of pain on row functioning is dependent on PTSD, or conversely, the effect of PTSD on row functioning is conditioned on pain. So all three of these conditional effects are sort of moderated or sort of contextualized within this interaction. Okay, and so if I wanted to go through and provide an interpretation of these conditional effects, I would say this is, based on my model, this is the unique effect of pain on row functioning, controlling for opiate use at average levels of pain, average levels of PTSD. Okay? This is the unique effect of opiate use on row functioning at average levels of pain and PTSD. This is the unique effect of pain on row functioning at average levels of pain controlling for opiate use. Okay, this is super important. Do people see kind of why sort of I'm interpreting these effects in this way? Okay, so again, the key to these multiplicative models is always being clear on what zero means, and then making sure that your interpretations are consistent with that. Okay, so here, my conditional effect of pain controlling for opiate use and average levels of PTSD, I've got clear evidence there. It looks like, and we had saw this before, that opiate use doesn't appear to have a unique effect of PTSD, opiate use doesn't look like it is uniquely associated with row functioning, at least at average levels of pain or PTSD. If we switch those around, that could change, right? And it looks like we are getting evidence of a unique effect of PTSD on row functioning at average levels of pain controlling for opiate use. But these individual coefficients are all going to start shifting around depending on what values we're looking at. Questions on our interpretations here? Okay. And then these are our standardized coefficients. We're not interpreting those because those aren't correct. But these are viable standardized coefficients for our conditional effects here. Confidence intervals, part and partial correlations, all that stuff. Okay. All right. So we're seeing evidence for a unique sort of an interaction effect of, a conditional effect of PTSD on row functioning at high and low levels of pain. Let's tackle that one first. So what do we want to do in order to test this?
Recenter where the moderator falls based on high and low.
Exactly, right? So what I'm going to do is I'm going to create a new set of interaction terms, right? So I'm going to say compute. Well, what we would also do is we would go through, take this these coefficients, run that out, factor my equations, plot my simple slopes, all that type of stuff, right? So we'd want to go through and do that. But we're going to skip ahead to just actually wanting to go through and test at high and low levels. So what I'm going to do is I'm going to compute. And CJ, what's my moderator here?
The moderator is pain.
Yep. So I'm going to create a variable called high pain, and that's going to be equal to my centered pain variable. What?
Minus a standard deviation.
Yeah, perfect, right? And this is tricky. High pain, it seems like we should be adding a standard deviation, but we're not. We're subtracting to get high levels of pain. So we're going to subtract standard deviation here for pain minus 1.34187. Okay. All right. And then you're going to do the same thing. And this is another reason centering is nice, because I can just change this to low pain, pain, whoops, plus that. Okay. If I go down through and I run that, I now have values where 0 now corresponds to high pain and 0 corresponds to low pain. And so now what do I need to do?
You need to make a new interaction term.
Need to make new interactions, right? And it's important here because pain is incorporated in a couple of different interactions. And so what I need to do is make sure that I'm creating interactions for everything that pain is involved in here, right? So I'm going to go through I'm going to compute high pain times PTSD, right? And low pain times PTSD. It's going to be high pain times centered PTSD. And here, I'm going to take low pain times centered PTSD. Okay, so that's one set of interactions, but then I also have pain involved in this opiate use, right? So I need to go down through and I need to create a couple more interaction terms. That's going to be high pain, opiate use, low pain, opiate use, and I'm going to substitute high and low pain with centered opiate. Okay. Then we can go through and I'm going to run these. Okay. So if I look at my data set, I now have a variable centered at high pain and low pain. And then I've got high pain times PTSD, low pain times PTSD, and high pain times opiate, low pain times opiate. So now what I want to do, what do I want to do?
More regressions for low pain or high pain.
Right. Always more regressions, right? So here, we're going to go down through, and I'm going to go through, run a couple different regression models, right? But this time, instead of having for this first one, I'm going to substitute low pain, right? And then I'm going to have low pain times PTSD and low pain times opiate use, substitute for both of those, right? And then the same thing, I'm going to have high pain, substitute high pain here, opiate use PTSD, and I'm going to have high pain in PTSD, and low pain and PTSD. Okay. So the bad news is this is a lot of different steps and a lot of different spots where you can go through and get things turned around and get kind of lost and confused with stuff. The good news is this all follows a systematic pattern that's easy to go through and check and verify. If you have fail-safes in, if you're going through and making sure that everything squares up, you're going to get it right. Now, you'll make mistakes. Everybody makes mistakes. I still make mistakes. I've been working with Layla on her thesis, and we've been sort of working through a lot of stuff, and there are hiccups. You forget to center something, or then you kick somebody out, and then not everything is centered correctly, and you have to re-go through center. It's a hassle. But it all develops in a semi-orderly fashion that you at least have a record of and you can go through and check. Okay. Questions on what we've done up to this point? Okay. So what we can do now is we can go through and we can run these regressions. Right? And what I'm going to do here, just to help things out. So this is my overall model. I'm going to delete that, get that. All right. And then, all right, here. Okay. So I can see if I've done this correctly. What I should see is that my interaction terms don't change across my three models. In 4 point here, here, here. Tomorrow, do I have any problems with my interactions? Nope. And tomorrow, what's my moderator?
Don't we have two?
Well, but within this simple slopes model, what's the moderator I'm interested in? Pain, right? And if I look at the coefficient for my moderator, it's all staying the same, right? But if I look at my other coefficients for my constant, that's jumping around, right? Because what 0 means starts to change depending on where I'm at. And then my conditional effects are jumping around, which is good because they should, because I've switched things around. Okay. But for all of this stuff, what's the only thing I'm interested in with these models?
Hey Josh, is there a problem with the last one?
What do you mean?
Looks like the regression has low pain in it.
Oh, whoops. Yep, you're right. Good catch. Good work. There we go. Perfect. Good work, Sean. Yeah. Okay. So now with my correct model. See, what did I tell you? You're going to make mistakes. It happens. What's the effect that I'm interested in? So here's my overall model. This is the model that was just with my what I would think about as my base model. What's the only thing I'm interested in with my low pain model and my high pain model? Why did I do all this in the first place?
See if it moderates PTSD and oral functioning.
Okay. Well, so do I need these subsequent models to tell whether or not pain moderates the relation between PTSD and outcome? No, because I already got that here. So what am I looking at? Low pain and high pain.
If they're significant.
Yeah, if my conditional effect is significant. And so this is what, it's weird. It seems like you're doing a lot of work, but the only coefficient I'm interested in here is this, is this conditional effect of PTSD. this is my conditional effect of PTSD at low levels of pain. And here, this is my conditional effect of PTSD at high levels of pain. Do I care about anything else, any other coefficients in this model? Nope. Outside of using these other coefficients to make sure that I've done this correctly, nothing else in these simple slopes models matter. The only reason I'm doing this is I'm just hijacking SPSS to give me a test for the statistical significance of the conditional effect of PTSD at low levels of pain and the conditional effect of PTSD at high levels of pain. Okay, nothing else matters. This effect and these effect sizes are the only reason that I'm doing this. Outside, once I've made sure that everything is identical, I don't care about any of this other stuff. Does that make some sense?
You're also interested in the opioid one, correct?
Yeah. We will go through and we won't get to that. We'll start on that next week. But yep, and then what we would do is we would go through the same process to probe the conditional effect of opiate use in pain as well. And that's going to be a little bit different because opiate use is a dichotomous variable. So we'll play around that. I mean, that'll be a little bit different procedure, but it still follows the same basic steps. Okay. So the take-home message here is that you can, with just your base model that you get in your original interaction model here, right? You can derive your simple slopes, right? You can get your simple slopes at high and low levels of, for PTSD at high and low levels of pain. You can derive your simple slopes for pain for users and non-users. You can go through and you can plot your simple slopes, right? The only thing that you need these subsequent analyses for is to test whether or not you have evidence for a unique effect at high and low levels, or if what you're seeing here is just general noise. Okay. It seems like a lot for just to get a test of those simple slopes. But does this make sense? Questions at all about this procedure are kind of what we're trying to do. Okay, cool. Well, what we'll do is we'll pick up with running the simple slopes for opiate use, or the conditional effect of pain on outcome for users and non-users. But if we're just thinking about this, I've got a dichotomous variable with 0, no use, 1, and no use. How might I flip that, or how might I manipulate that to look at the conditional effect for users of pain on role functioning for users and non-users?
Just plug in 1 and 0?
Yep, that's all you're going to do. We're going to go back through and I'm going to run this base model. Pain, PTSD, and opiate use. Except what we're going to do is, instead of using centered opiate use, we'll just use opiate use, because 0 means no use and 1 means use. I'm going to have to create a new interaction term with the uncentered variable there, just so everything squares up. But again, with just my dummy indicator here, 0, 1, this is looking at the unique effect of pain on role functioning when everything else is held constant at 0. Well, when opiate use is held constant at 0, it corresponds to people who aren't using, right? And Sean, ideas on how I might look at the unique effect or the conditional effect of pain on role functioning for people who are using.
Reverse code that opiate use.
Exactly. Just flip that around. And now I'm going to recode that opiate, that dummy variable. So 0 indicates is corresponding to users and 1 corresponds to not users. is then I just run the same model with the reverse coded variable and the modified interaction. And now I'm getting the conditional effect of PTSD on outcome for users there. Okay. So this is a tricky process, right? And there are a lot of ways that it can go backwards, right? I forget a minus, or I sort of swap out a sign or something like that, or forget to center one of my variables, or use an old variable, or create an interaction term. It'll start throwing things off. But the nice thing is, again, if you've done it correctly, this is what you should be getting. This should be the pattern every time. And as long as you are getting that, you are going to be okay. Okay. So it's nice. This is a complicated analysis that's going to be a headache, but there's a lot of fail safes in there that you can go through and double check your work. So definitely do that. And if you find something that's off, don't assume that, oh, it's probably okay. It probably means you've made an error in there somewhere. Okay. Questions? How are people feeling? Good. Who's feeling demoralized? Okay. So we got one honest person.
I'm pretty good. Demoralized.
You're feeling demoralized, Chris?
Yeah, I'm just tired of all this.
Yeah. How about this? How about this as a moral booster? We're not going to worry about like a semester exam this semester because everything's funky and weird. So we're just not going to screw around with it. How's that sound?
That sounds good.
Pretty good.
Okay.
I wasn't trying to elicit that response, to be totally honest with you. But
Well,
Good
that's
work anyway.
that's turns out it's crazy to imagine, but sort of my decisions for your education don't hinge on sort of what Chris is eliciting, but
well, it's just a humble lad thinking I was helping.
right. This is tough. There's a lot of stuff going on. I mean, I was gonna stick with it. I mean, and I guess sort of the thing is then what ends up happening then is and I guess, I mean, this seems fair to me, sort of we're going to pull that semester exam out. And so then your scores on your problem sets are just going to be 90% of your grade. And then the quiz that we took in class will just be sort of 10%. Does that seem reasonable in terms of calculating things? People comfortable with that? Cool. All right.
I have another quick question.
Yeah.
Are you against like the use of like moderation programs for SPSS?
No. So if you wanted to use process and are familiar with process for doing this, I think that would be a good thing to go through and use. Now, to clarify, process for moderation doesn't do anything different than what we've done here. There's no reason to bootstrap anything. There's no concern with the standard errors. Process streamlines it. It makes it easier. And Alicia, there are shortcuts that I'll give you in Stata that make this much easier so you don't have to go through and calculate a bunch of different terms and things along those lines, which is nice. But like anything else, those are tools that you need to know what they're doing and why, and to be able to be confident that the thing that got spat out on the end makes sense. So Chris, and in your program, you guys have sort of been exposed to process and using some of those tools. Is that correct? Okay.
I've used it a couple times.
Okay. And so if you wanted to go through and double check your work in process to make sure everything maps on, I would strongly recommend you using all tools at your disposal to go through and do that, right? But what I start to get concerned about is people using tools but not understanding how they work or why they work, and then getting ridiculous nonsensical results and not recognizing they're nonsensical, and then sort of inadvertently presenting that as like, oh, this is what it says. So want you guys to be solid on sort of the process of going through and understanding how all this stuff works. But yes, absolutely, if you have sort of things that you can go through and double check your work. There's just so many places to get turned around with this that's absolutely a good idea. Okay. Awesome. All right. So, Friday at noon. People still fine with Friday at noon? I mean, time is, it's no more apparent that time is a sort of just a construct than during lockdown and a pandemic, because Sunday evening, Tuesday morning, who cares? Like, it's all the same difference, right? But let's go through and keep Friday at noon as the deadline for submission for problem set 3. Go ahead and send your same thing, data set, write-ups, everything to Laura. Laura will go through, score those. She's got some things that she's going to do. I'm probably going to go through and then print those out because I'm crotchety and sort of an old guy and I like to scribble on things. But then we'll just go through and sneak over to the department and PDF those once I've made sort of marks and stuff like that so that you have that for your own records. Okay? That sound good?
So pictures of hand counts are still fine?
Yeah, absolutely do that. Yep. So yeah, but outside of problem 1, I don't think that you should have any hand calculations outside of that first set. Oh, other thing too, in terms of, did people take a look at the example write-up that I provided? I sent you an update on this. Yeah. Okay. Make sure that you go through, take a look at that. That'll help you sort of see maybe how to go through and start to frame some of these things, some of your regression stuff. Also, yeah, so I gave oh, that's for screening. Okay, well, yeah, here. All right, real quick. So I've included a general like sort of example write-up. So go through, take a look at this. But in terms of for your S values and your Bayes, again, do not feel like you need to make a literal interpretation of these every single time you present them. That's not necessary. Save yourself some time. If you want to, if it makes sense, if it helps communicate an argument, go through and do it. Otherwise, you don't need to worry about it. But for Laura and I trying to figure out who's done what with what, you could, something just like this, just say p-values, S-values, Bayes factor calculated from, well, that's from exact P. I'm sorry. There we go. Okay, that's what I'm looking for. Yeah. I mean, if you can just put a footnote that says if you're literally going through and double clicking that and then dropping that into your Excel, just say exact value copied from SPSS output. That's going to be fine. Okay. That will reduce confusion in terms of who's doing what with what, and save us a great deal of time in terms of how you're getting the variables you are. So if you're just taking literally that, dropping it in here, cool, just tell us that that's what's going on. Okay. And that's probably going to be the simplest and easiest way for you guys to do things. I'm not sure why you would do anything other than that. But if you do, if you're going to, you know, march to the beat of your own drum, just sort of be clear on what you're doing with stuff. Sound good? All right, folks. That does it. Good work. thanks for hanging in there. If you go through, Chris is, we got no points from Chris, so fine. Yeah, let me know if you're running into snags. And otherwise, have fun. I ran out of words. I've had too many words. I said too many words. All right. We'll see you guys.